We don't ever really answer a science question and ask a simpler one afterwards, right? Science gets more complicated and we ask more complicated questions and we want more advanced things, right? We want better medicine, we want better batteries for our phones, we want improvement, right? So in order to do that, you actually need a system today that's not only as capable as Aurora is in terms of computation, but as capable with AI as Aurora is.
One of the things that you have to understand about a large specialized supercomputer such as Aurora, you can't go pick it up at Best Buy. It takes engineers, scientists, system administrators, management. We had hundreds of people working on this project to make the system of this scale, this complexity, work well and smoothly so the users can just use it. Being able to stand up a machine like this is a real pleasure.
Aurora will be able to combine high speed, high performance AI, simulation, and in some cases incorporation into complex workflows that are really what the future of computational science looks like.
I think the thing that I'm most excited about now that Aurora's entered production is the ability to get any and all users on the system. That allows for an endless amount of possibilities.
Having access to this AI hardware is really important for the research community so they can experiment and play and learn it. We want individual researchers to be able to progress as fast as they can think, not as fast as their computations are.
We're trying to use AI in our research to really advance our cancer models and allow us to understand, the trajectory of cancer cells, the effect of different properties of the cancer cell, like its size, its deformability, to build patient-specific models to essentially create a digital twin of the human that physicians can use to find disease and diagnose disease better, track the patient over time when they're not in the physician's office, and inform the treatment of disease. So it's allowing us to interact with this data in a way we never could have before. And just in general, it's a lot of fun to play with the world's biggest supercomputers and see what you can do with that. So we get to do a lot of exciting things through this research.
The cosmos was the first thing that humans ever really studied systematically. We see obviously the sun and we see the stars and they move, and the fact that they move in regular patterns is how people actually started thinking about science. The fact that we have computers large enough now that we can actually put in the equations that describe how the universe should evolve and compute them is really quite remarkable. One of the very exciting aspects of exascale machines, and Aurora in particular, when something's become very complex, often you don't really have a good idea of how to analyze the data without using artificial intelligence and machine learning methods. And because Aurora has 60,000 GPUs, we can actually apply these extremely powerful techniques. The fact that it's a compute engine, the fact that you can do data-intensive science on it, and the fact that it's an AI/ML machine make Aurora extremely useful for us.
Fusion research is to create almost perfect energy source. It's safe, and also the energy source can last almost forever. And it's a very ideal energy source for mankind. AI, machine learning, is expected to play an important role in our simulation. Number one, there are places in our kernels, in the computational kernels, where we think those kernels can be replaced by trained AI models, machine learning models in there. And those are expected to be much faster and much simpler. If we can cut the simulation time by half on Aurora, think about the savings you're going to have.
I try to simulate materials on a computer. So I'm able to build materials atom per atom or electron per electron. But instead of doing it on a bench or experimentally, we do it at the simulation level. We can really analyze all their properties. We can change things. We are building something, or at least we understand how things work. The power of doing it on a computer gives us the whole freedom of taking risks, because one of our biggest challenges was, do we do something that is very accurate but perfect, which is not the nature of life, or do we do something that is closer to life but not so accurate? Aurora really is that bridge that connects this high accuracy requirement and real life type of simulations. This new system allows us to dream a little further. It is going to allow us to study so more complicated things. All the things that we were always told, this is too large, it cannot fit in the system, we cannot study it because it's impossible. Now we can.